Greetings and welcome to the Introduction to Astronomy. In this week's Astronomy of Other Cultures, we are continuing our talks on Muslim astronomy, and we'll talk about Nur ad-Din al-Bitruji. So let's find out what he contributed to astronomy. Now, Nur ad-Din al-Bitruji, also known by the Latinized name of al-Bitruji, lived until about 1204. And worked on astronomy in what is now Spain, which was part of the Muslim world at the time. Now, in astronomy, he reworked the model to get rid of the epicycles and eccentrics, and we've talked about this over the last few videos with various different astronomers of this era leading up to this, but what he did was to get a model that redid things and made a model of concentric spheres that were centered on Earth. Now, how did that help? Well, the whole idea is that we're changing kind of our understanding, that we're looking at the physical reasoning now. Now, the problem was this was less accurate than Ptolemy's model. So it still wasn't realistic as what we know today. We, of course, know today that the Earth is not at the center and that the Earth is one of the planets that orbits around our sun. But there were still concerns with the geocentric model at this time, and we hadn't quite gotten to that jump to get Earth out of the center. So while this model was trying to simplify things by getting rid of the epicycles and eccentrics, because it was less accurate, that was difficult, because you want your new model to be more accurate, to do a better job of everything. Now, this was actually a physical model. So in order to explain this, this was different than what Ptolemy had done. Ptolemy had made a mathematical model, a way of predicting the planets' positions. This is meant to be an actual physical cause to the motions of the planets. So actual physical connected spheres that would then cause things to move here. So something like this to explain how an object would move around the Earth. And you'd have various different spheres all interconnected with different motions, which would then go together to reproduce the motions that were in the sky. Now, the nice thing was, this did not need epicycles, so no epicycles needed in this case, and that was really one of the problems people had. The celestial impulse, whatever was causing this, that was transmitted from one sphere to the next, that caused the motion. And we're really beginning to see some of the beginnings of the relation of physics and astronomy. Astronomy earlier than this was really the prediction of the positions of the planets. That's most of what was done at the time, was to figure out where the planets were going to be. Remember, the stars were fixed, they didn't change, and there were just these 5 planets that wandered among the stars. So they were the ones that we really had to figure out their positions of accurately. And we're now trying to get a physical reason. And over the next few hundred years, we'll start to see this become more and more important as we move into the time of the Renaissance and then into the time of Isaac Newton, really beginning to contribute these two. And we should note that this work was noted by Copernicus. So the work of al-Bitruji was noted by Copernicus in his work as well. So let's go ahead and finish up with our summary. So what we've looked at today was the astronomer Nur ad-Din al-Bitruji, also known as al-Bitruji, who lived until about 1204 and was known for work in astronomy in what is now Spain. He developed a physical model that was used to explain the positions of the planets that did not require the use of epicycles or eccentrics. So that concludes this discussion on al-Bitruji, or Nur ad-Din al-Bitruji. We'll be back again next week to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.